Okay, Wildcats. Today we're looking at journal page 2, sets of numbers and notation. Vocabulary. Set, a collection or group. Element, an item in a set. Subset, a set within a set. Empty set, null set without elements. Finite set, limited number of elements. Infinite set, unlimited number of elements. Notation. Roster list, set builder. I should say roster list is also known as set builder. Example 1, alphabet. Example 2, positive even numbers. Inequality. Use inequality symbols. Now, what's important to note about inequality symbols is they're read from left to right and right to left. So this says less than, but it also says greater than. This says greater than, but it also says less than. This says less than or equal to, but it also says greater than or equal to. This says greater than or equal to, but it also says less than or equal to. So what I mean, let's look at example 3. Example 3 says x is less than 2, but it also says 2 is greater than x. Or x is greater than or equal to 5, but it also can be read 5 is less than or equal to x. Now example 4 says that, and basically we can look at the left and right, but because x is in the middle, let me explain it this way. Really, x is greater than or equal to -1, but less than 2. So basically what it's saying is x is between -1 and it could include -1, but less than 2. Interval all symbols. So you have parentheses, brackets, and you have the or and symbol. Now, parentheses mean less than, greater than, but brackets mean less than, equal to, and greater than, equal to. So basically, parentheses, not equal, bracket, equal to. Now, when it's not equal to, it's going to be an open circle. When it's equal to, it's going to have a closed circle. So, example, this says from -infinity to 2, not including 2, or 5 to infinity, including or equal to 5. Okay. Example 6 says the numbers are between -1 and 2, but it could equal -1, but it cannot equal 2. All right, so if you would, finish up your notes. All right, now your notes are completed. Let's take a look at sets of numbers, okay? Now, at this point, I don't know if you've noticed, but I tore the papers apart and I reordered them for this video, okay? All right, so let's look at the first. Now, what we're looking at is all real numbers with the symbol we write as a double R, okay? And when we say real numbers, what we're saying is all numbers on a number line. All right, now let's start with natural numbers, which the symbol is a capital N. Now, natural numbers are part of real numbers, okay? Natural numbers are 1, 2, 3, ... okay? Now, natural numbers are a subset of whole numbers. Which is equal to capital N. Now, whole numbers are 0, 1, 2, 3, ... Okay? Now, natural number is a subset of whole numbers, and whole numbers is a subset of integers. Which integers are represented by the capital Z. Now, integers are -3, -2, -1, 0, 1, 2, 3, and you can go ... to the right and ... to the left. Okay. Now, natural numbers are a subset of whole numbers. Whole numbers are a set of integers. And natural number and whole numbers are a subset of integers. Okay. So now these are all subsets of rational numbers, which we represent with a capital Q, which are plus or minus fractions or decimals. Now, what's important to note is when we say decimals, what we mean is that they're terminating or repeating. Okay, now these are all subsets of real numbers. Now, a natural number can be a whole number, but 0 cannot be a natural number. Okay, so 1 can be a whole number and a natural number, but -1 can't be a whole number or a natural number. Okay, all right, so now we need to incorporate irrational numbers, which is a special subset of real numbers. Now, irrational numbers are non-terminating decimals. So pi is the most famous of non-terminating. There is no end to pi. It's 3.14 number, so on to the so on. Okay, square root of 2 and square root of 5 are examples of non-terminating. Okay. Now, since I showed you some examples of non-terminating, let me go back and terminate. So an example of terminating would be 1/2. Because 1/2 is written as 0.5. That's a terminating decimal. Okay. But 1/3 is repeating. So 1/3 is 0.3333, so on. Okay. All right. Now, let me turn this way. And this is, again, will be included on page 2 in your journal. Okay. So far in your journal, this is part of page 2, and this is part of page 2. Okay. All right. Now, the last part of journal page 2 is your examples. Okay. All right. Interval and inequality notation are the most commonly used forms of notation. Inequality notation can easily be written in set builder notation as well. Parentheses indicate those values that are not equal to, and brackets indicate those values that are equal to. Okay. So interval notation uses parentheses and brackets. So when we say x is less than 2, we're saying that's from -infinity to 2, not including 2. Okay. Now we know from our notes that if it's not equal to, that's an open circle, and if it's equal to, it's a closed circle. Okay. So we have an open circle at 2. So a little lighting adjustment. And then we're shading to the right. Okay, example 2. Now, what we're saying is x is greater than -1, but less than or equal to 3. So in interval notation, What that means is that's from -1, not including -1, or not equal to -1, to 3, but equal to 3. So we have an open circle at -1, and we have a closed circle at 3, and we shade between. All right, example 3. Now here we're given interval notation. We have to write it as inequality notation. So what that means is x is between -4 and 5, not equal to -4, but equal to 5. So that's -4 less than x less than or equal to 5. So on our graph, what that looks like is we have an open circle at -4, and we have a closed circle at 5, and we shade everything between. All right, now here we have interval notation. Now this is the most complex of the examples so far because we basically have interval notations separated by the or statement, okay? So in inequality notation, what that looks like is, and there's not enough space in this box, so I'm going to write it below here so I can write it all in one statement. So that's -1 less than x less than or equal to 0, or x is greater than 2. All right. Now, what that looks graphically is we have an open circle at -1, and we have a closed circle at 0, and we shade between. And then it's, or we have an open circle at 2, and it's greater than 2. All right, so let's take a look at example 5. On what intervals of x is f of x decreasing? Okay, so it looks like it's decreasing here. Again, going from left to right. Here's increasing, it's decreasing. So here it looks like we're at 2. So it's decreasing from 2 to infinity. Okay. Now, on what intervals of x is f of x? Now, here's x. This is f of x. So we're looking from left to right, but we're looking at the f of x. So here, all the values of f of x are negative from negative infinity to positive infinity. Okay. On what intervals of x is f of x positive? Well, the answer to that is none. None of the graph is in the positive f of x. Then it says on what interval of x is it constant? Now, constant would be this. So imagine the graph was like this. This is would be your constant section. That does not occur here, so there are none. Okay, so with that, if you would, finish up your examples and start working on your assignment, and have a wonderful Wildcat day.